Hey, good day to you all, those who are interested in artillery matters. And today is a special day. Uh, you will get familiar with this beauty. As I told you, I'm using an old outdated Tushino mode. I hope they don't mind if I'm using it, and I translated it. And I just finished translating the Grad, the BM21 part of it. So you have the possibility to play around with the Grad. And I have to tell you that the Red Hammer Studios, the basic version, is somewhat very boring, but this one is awesome. I have not really used, in reality, one of these myself, though I have seen them. But I made some research, and I can tell you that this is just as real as you can get to the. I mean, the Tushino mod is just as real concerning this BM21 Grad, just as real as you can get to the real thing. And you will be surprised that, well, man, this is a war machine. You can. It's cheap, effective, simple, and in a couple of hours you can explain to a man with some basic arithmetic and trigonometric skills how to use it, and you can just unleash hell in a 20-kilometer radius. So let's get into it. So well, it's going to be long. Bear with me. It will not be short and easy. Well, if you want to learn something, you need to take the time. If you're interested in it, at the end, I promise you will be a seasoned BM21 Grad operator. What you need is obviously your BM21 Grad. You need a guy, and you need your aiming circle, if it is the aiming circle, and an aiming pole, because we will use some different methods to, let's get to the driver. He picks up the aiming pole and get into the car. Get in as a driver.
Садись в машину. Ты за рулем.
And let's get to the officer. He takes the command's position, and we are out for our mission. What is our mission? Let me show you on the map. I have this position where I'm starting here in Sofia, and I should drive somewhat south, and I need to reach my launch position where I set on my BM21 Grad, and we are going to engage the airport here because we have some intel that high value targets are on the airport. Let's get into it. So we need to start going to the south, which is pretty much where we are going to go now. Now you see at the end of the road we need to turn left. Live ABS and all that fancy electronic stuff, because you will be surprised at the end. So where are we? We are in this intersection. We turn left and get to our launch position. Defined position that we are going to shoot this direction, which is what must be around 4,000 mils, or 230 something degrees, 230 something degrees. So if you look at the Grad from outside, you need to understand that if we are turning our tubes, we need to turn our tubes on leftward instead of rightwards, because you have the aiming circle, or the panoramic periscope you have on the left side of the tubes, launching tubes. So you want to turn the tubes leftwards in order to have the freedom of movement around the aiming periscope, and also you don't want the cub, the truck, the cub of the truck itself, you don't want to be in the path of the tubes, so you want to rotate the tubes at least 70-80 degrees leftwards in a way that it faces your target. So to do that, we need to position our truck at least north. So if you're sitting here, you see, we need to turn left. As north as possible. Well, not yet. That's good. Let's get out, and our truck now, I think it's pretty much positioned in the right way, because when I'm going to rotate the tubes, it will face that way, and I am going to work on the back of the truck. You see, that's why you always see on the videos when they use this, they are always they're trying always to turn the tubes leftwards instead of rightwards, because you see the panoramic sight is on the left side. If you can rotate the tubes right if you want, but you will be very comfortable working here, and you also have very limited visibility with your panoramic sight to for the orientation point and whatnot. So this is the best way to set up your truck if you want to use it properly. Okay, let's take to the driver's place. He also gets out. Now first, obviously what you need to do is to determine your position, but before that, this this mod wants us to level the truck. Okay, so let's speed up the things, and with leveling you need just to level out the truck. I don't know how they do it in reality, because I don't think they have adjustable wheels or whatever. I think they're just looking for some horizontal place, but that is how in the game you level your truck. Okay, the second thing you need to know is where you are exactly, because you need to determine your position pretty precisely. And in order to do that, you go to your driver, and he just gets to a fancy position what you see, but and you can determine like the intersection of that road. That's fine, totally visible. Why we are doing that? Because we are going to use another method to determine your position, and that method will be the angle and distance method instead of just two angles method. So we assemble the aiming pole, and with this mod you can change the aiming pole into a plank, into an artillery plank. The artillery plank, why artillery plank are fancy? Because you can measure distance with it. So let's aim on to our launch position. You just release it and you level it that it will be totally horizontal. Why am I aiming to the launch position? Because in that way it will be perpendicular to my sight, and just by being perpendicular to my sight I can measure distances. And let me show you how. So you see, there he is, and I need to set up my aiming circle here. Cancel. Why is this cancelled? I don't. Let's get to. I need to be at about the same distance here. And I'm just trying to set up my aiming circle. Okay. Well, I should have speed up things. Anyway. Why am I doing this? Because I want to determine the position exactly. Yes, you can have rangefinders and all that stuff, but I just want to show you that what aiming circles are also not only good for determining angles, but also good for determining distances. How it is that I get into gunner? I'm trying to aim to my friend, and you see I have the artillery pole there. What I do is, you have the upper scale, which has this 50, 60, 80, whatever to 400. This is a distance scale, and this is calibrated for 2 meters. So if you align the rightmost mark with the edge of a 2 meters aiming pole or aiming plank, on the other edge you can see the distance from that alien patch, which in our case it is 72, 4, 6, 8, 79 meters. You see? So we are 79 meters from that aiming pole using our distance scale on our aiming circle. And it can pretty much, pretty easily measure distances pretty accurately, up to 10 meters accuracy what we need for artillery. 79 meters, all what we need is obviously the angle. So we get out of the aiming circle, we need to pack that. We need to pack the aiming circle, because here you cannot really use aiming circles. We need to go for about pretty significant distance from the big piece of metal to use it properly. Anyway, what we need is the angle to that, and we know that it's 79 meters, and it was this intersection. So what we need, that was the northern intersection, this intersection, and I just put my sight on the intersection, and I know that this is 79 meters. I have also modified the compass, that it is now, the scale is good, that one of these units are 100 meters. So it is 279 meters from that would be 20, 40, 60, 80, so somewhere like 60, 79, it is like at the 80 mark. So this is our launch position. So you see we pretty closely got to our launching position, and we also determined our position, and what we need now it is to determine our target distance and azimuth. Well, for that I bring up the 6000. That is an easier map tool. I like to use it better because it is somewhat easier, and you can I have tired eyes, so I don't like those map tools. I need to use this one. Anyway, the azimuth is 4,213 mils. The elevation is 18 meters for my target, and the distance is, I measure distance on the back because I think the distance should be the same both ways. That is 11,860 meters, and my elevation is 14 meters, so the elevation difference is plus 4 meters. Let's put it into our notebook there. So the target range is 11,860 meters. The azimuth is 4,213 mils, and the elevation difference is plus 4 meters. Good. Now comes the most hated part, the calculation part. Well, what you need it is obviously your range table, and knowing that your distance was 11,860, what you need it is to pick, what are these two, the other range table things. The BM-21 has an interesting feature. You can attach to the rockets brake rings, which will change the aerodynamics of the rockets in a way that they will fly in a shorter trajectory. So instead of changing the charges, which is impossible with a solid fuel rocket, you can just attach some brake rings and it will be different. It will go shorter, and if you want to shoot higher angle, or you just don't want to shoot to 20,000 meters or 20 kilometers, you can attach a M or a B brake ring in an interaction manual. It's very interesting, and it is very, well, it is very fancy. I mean, it's just incredible that they modeled this one also. They did not model the different fuses, but they modeled this. This is wonderful. So what was that? 11,860. So our closest to that is 11,800. Yeah, 11,800. So we need to put down the numbers. So our base range is 11,800. Our base elevation will be, let's see, 179 mils, 179 mils. Our range change for 1 mil, is 43 meters. Our elevation change for 50 meter range is 2 mils. Our elevation change for 100 meters of elevation difference is 1 mil. What is the derivation or drift is minus 4 mils. We don't have side wind correction for this distance, but we have headwind. Side wind correction is 0, but we had headwind correction, we have 11 meters. The temperature correction is 150 meters, and the pressure correction is 38 meters. Density, I also, well, you can calculate the density, but it doesn't seem to be implemented in the game, so don't bother with that. In fact, in the real BM-21 range table, they don't calculate with density. They calculate with temperature, whatever, a lot of things, but not with the density. So let's get to our calculating table, and we just need to fill it up. The base range was 11,860 meters. So our base elevation was 11,800 meters. The range change for 1 mil was 43 meters. Elevation change for 50 was 2 mils. Elevation correction was 1 mil. Drift was minus 4 mil. Side wind correction was 0. Headwind correction was 11 meters. Temperature correction was 150 meters, and the pressure correction was 38 meters. Now we need to go to our meteor report. What our meteor report says that we have what? We have 23.9 degrees temperature. So the temperature is what? 23.9 degrees. the pressure is 1008. 1008. Let's just forget about the 0.11. Side wind and headwind. We have a wind direction of 174 and 4.1. We need to plot that out. We need to plot that out. We need the normal map tools. And we need to plot out the side, and we don't really need the side part of the wind because we don't have side wind correction, but we certainly have headwind correction. So what does it say? 174 degrees. 174 degrees. Let's turn it to here. Is 174. 174, 175, and this 4.1. It's 1, 2, 3, 4, 4.1. So this is our wind. This is our wind vector. And we are shooting at this direction. So we turn our plotter into our direction, and we see that we have what, a 1, 2, 3, 4 meter per second side wind, but we don't have side wind correction, and we have about 0.7 meter per second tailwind. Which the tailwind is interesting because with the tailwind it wants to add to our range, so it is going to be negative correction. So we have minus 0.7 tailwind, headwind or tailwind, minus 0.7 tailwind. The side wind correction. The side wind is 4, but we have 0. We don't have to correct for them. Side wind correction is 0. So let's calculate what is our range compensation, range correction. It is the target range minus base range multiplied by elevation correction for 50 meters per 50 meters per 50 meters, and that's what you get your range correction. The target range was 11,860 minus 11. Nope. Yeah, I just mistyped. It's 11,800. It's not 11,860. That's our target range. The base range is not that. So 11,860 minus 11,800 multiplied by elevation change range correction for 50 meters is 2 mils by 50, and that means 2.4 mils. So our range correction is 2.4 mils, and since we are shooting low angle here and we need to shoot further, we need to elevate our barrels. Elevation correction, we have 4 meters of elevation change. What we need is the elevation correction number is 1 mil multiplied by our actual elevation difference is 4 meters divided by 100, and that equals 0.04. But at the end we will add the all together, and since the target is higher, it means I want to shoot further. That means shooting low angle, that is a positive correction. Headwind correction, we have what? The headwind is minus 0.7, and the headwind correction is 11 meters. So 0.7 and the headwind correction is 11 meters. That means 7.7 meters. I need to aim 7.7 meters shorter because I have tailwind. 7.7 meters shorter. Side wind correction, we don't have side wind correction. Temperature correction, that's 15 minus the actual temperature, which is 23.9, and that multiplied by temperature correction, which is 150 meter by 10, that equals, well, that's pretty significant temperature correction because I have minus, so my 133.5, because the temperature is higher than the base temperature, but the range table is calibrated for 15 degrees. That means in the thinner air, the rockets wants to fly further, so I have to aim 133 meters shorter if I want to hit that target at that distance at that temperature. That's funny, isn't it? So the pressure correction, let's calculate the pressure correction. You need the actual pressure, which is 1008 minus 1013.25 multiplied by the pressure correction number, which is 38 by 10. So you get, no, that's impossible, I mistyped something. So pressure, let's do it again. The actual pressure is 1008 minus 1013.25, that is minus 5.25, and you need to multiply it with the pressure correction, which is 38 by 10. That gets, yeah, that is what I like it. Because the pressure is lower, that means I need to aim 19.95 meters shorter if you want to hit that target. So what you need as the add sum up all the meteorological corrections is the headwind correction was minus 7.7. The temperature correction was 133.5, and the pressure correction was 19.95, and that adds us minus 161. And I need to divide it by the range change for 1 mil, which was what? 43 meters. So that means 3.74 mils. That's 3.74 mils, but if all this is minus negative correction, so I want to aim shorter, so that is going to be a negative correction for my base elevation, which is 3.75 mils. Okay. So I also need to calculate the corrected azimuth, which consists of the target azimuth, which was 4,213 mils, and you need the sidewind correction, which is 0, and you need the drift, which is minus 4 mils. So that means it's 4,209 mils. But this is map azimuth, 4,209 mils. I need to find magnetic azimuth with my aiming circle. So from map azimuth to magnetic azimuth, you need to subtract 92. And that gives us 4,117 mils. So that's the magnetic azimuth I have to intercept. And I need the corrected elevation, which is the base elevation, which was, what was the base elevation? Base range, base elevation. What was the base elevation for that? That cannot be 11,800. Well, let's bring up the no, but the base elevation was 179 mils. The base elevation was 179 mils. So the base elevation was 179 mils, 179 mils. The range change was plus 2.4 mils, plus 2.4 mils. The elevation change was plus 0.04, plus 0.04, and the meteorological correction was minus 3.75, minus 3.75, and you get to 177.6, that's 178 mils. So that is our elevation you have to look for. So the magnetic azimuth you're looking for is 4117, and the elevation you are shooting is 178 mils, and you should be able to hit the airfield. So what first you need to do is to roughly orient your tubes to the desired azimuth, which was what? Which was 4,117 magnetic. 4,117 magnetic, and for that you need to open up your periscope, get into that as a gunner, and let's rotate it into, what was that, 4,100 whatever. 4117. That's 4000. 4100. That should be it. That should be it. Let's get down and level out everything. Level out the because it has to be vertical in order if we want to measure to it. You see, now it is vertical, and we also need to level out horizontally. No, that's 0 8, and horizontally we also leveled out the side. Now we just leveled out the side. Need to go a little further and set up the aiming circle. Get into it as a gunner. Let's find the magnetic north with it. That is the magnetic north. That's probably it. And our desired azimuth was 4117. So let's find the 4117 in the aiming circle. 4117. Good. Let's zero our goniometer, the counter angle meter, uglometer, which is angle meter. Let's get to 0. That is zeroed, and now we can turn our boussole onto the aiming periscope of the Grad and take the reading of the goniometer, which was 4733. 4733. Let's get out. The gunner. Let's rotate the goniometer onto the aiming circle somewhere. Let's turn down the periscope a little bit. Yeah, it's there. He is, and our aiming circle should be somewhere around that. Yeah, it's a little bit back. Yeah, it's over there. It's over there. So our reading was 4733. We need 4733. Set 4733 with the Y and Z and X, and with the arrow key. Now we rotate the entire stuff onto the aiming circle. That's it. 4733. Let's get out. Back to the aiming circle. As a gunner, and we are now compensating for the parallax error a little bit, and the new reading is 4734. 4734. We need to 4734 and rotate it onto. Yeah, we just set the azimuth and we need to set the elevation now. The elevation was 178 mils. 178 mils. Let's get back to the corner. This is the aiming periscope, and let's set with the page up, page down 100. Not with the arrow keys. What was that? 178. 178. And with the page up, page down, you now elevate the entire stuff until you see in the aiming circle. You go back at your sight is leveled again, and the vertical bubble is aligned with the middle. It starts to come up. And now it is fine. Good. So everything is leveled, elevated, everything is just fine, just a little bit. I think our barrels rotated a little bit, so we rotated back. Good. 4734. The elevation is fine. Everything is leveled. So we get out, get into the cabin. The commander's seat. So that we just set everything up. Let's see if we will hit our target. So here we need to check if everything works. This purple lamp, just if you push this button, will just say that everything is fine. You need to set it to automatic, автоматически. And here you set how many missiles you want to launch. It has its own sequence, so if you launch the first 10, you need to launch the second 20 or whatever. So let's launch all the 40 at once and see what we did. Okay, let's get to the camera view close to the airport and see if we hit anything. Yeah, you see, wonderful. Our missiles are just hitting the airport. We just calculated well. And I think we just hit our target pretty accurately. This is how this wonderful war machine works. I hope you enjoyed it, and you are in you just want to try it out. And I just will link the download link to this mod. That is 20 gigs, but it's well worth download it. And it does not work with the regular ACE or whatever. You have a lot of setbacks with it, because I don't think you can multiply it or anything of that sort, but you can pretty much get familiar with this piece of beauty. And I have to tell you, it's pretty realistic, and you're just surprised how simple and how reliable these things are, and how easy it is to operate them, because they are war machines. They are nothing else but a simple, reliable, sturdy war machine. I hope you enjoyed it, and have a wonderful day. Bye.